What's going on, guys? Welcome back to the channel. Today we're going to be going through the second part of the full guide of trigonometry. Now what's important here is that we're going to be going through much more equation orientated questions and also harder type questions that you're more likely to come across in exam. Okay, so the plan here is to walk you through a few examples, starting small and then going into more difficult ones, so that you've got a good idea of how to approach these in the exam. Obviously, I can't cover everything, like every permutation of what you'd be getting in the exam, but it's a good start, and these are the type of questions you'll be getting. As always, if you like the video, make sure to like, subscribe, comment, share with your friends if you're getting value out of these videos, and yeah, I'll see you in the video. Alright guys, so starting off here, we got a question that says to solve the equation exactly. Okay, and it's tan theta minus pi over 2 is equal to 1 within the domain of 0 to 2 pi. Okay, so how do we go about doing this? The key thing here is to firstly say, look, right, we can say that theta minus pi over 2 is equal to arctan of 1. Okay, which is going to give us what? Theta minus pi over 2 is going to equal pi over 4. Okay. And as a result, what can we say here? Well, we know, okay, we know that tan has a period of between 0 and pi. Okay, and so as a result, okay, with that knowledge, we can say this. Well, theta is going to equal 3 pi over 4 plus k times pi, okay, because we're talking in terms of multiples of pi. Now remember what our interval here is, 0 to 2 pi, okay, so therefore what we can say, get 3 pi over 4 plus 1 times pi, okay, what does that give us? That gives us 7 pi over 4, okay. And in terms of if we were to plug in -1 or 2, we'd be out of bounds. So as a result, okay, we've got 3 pi over 4 of the solution because if k equals 0, we get 3 pi over 4. Or we just get 7 pi over 4, which was demonstrated over here. Okay. And those are going to be your final two answers there. Alright guys, so here we've got an example of, so it's a pretty basic example. Okay, it's 2 sine squared theta plus sine theta is equal to 0. The trick is with these types of ones, okay, is to remember that, okay, it's a quadratic, okay? And we also need to remember that these are pretty simple questions as a whole, but how you solve them is very important. I'm going to show you why, because then that's going to build a foundation for you to build upon for those harder questions that we'll go through. So the way to solve this is to say, well, 2 sine squared theta plus sine theta, we can take out the sine theta. Okay, so we've got 2 sine theta plus 1 is equal to 0, right? And therefore what we've got is sine theta equals 0, or 2 sine theta is equal to -1, sine theta equals -half, okay, which means what? Well, if sine theta equals -half, okay, Actually, I'll leave that for now. I just want to demonstrate something quickly. If we stick to sine theta equals 0, we know that theta can equal 0 or pi there, right? Now let's focus on negative a half, right? If we draw our cast diagram, okay, this is our starting point, but we know that sine theta is positive in these quadrants, and we know it's negative in these quadrants, okay? Now the trick is with these kind of cast diagrams is we're actually going to draw the triangle itself, because this really helps to drive home the point. Okay, so I'm going to draw a right angle triangle here, and draw a right angle triangle here. Okay, if I put theta here, put 1 here and 2 there, 1 here and 2 there. Now why have I done that? Well, I've done that because sine theta is equal to negative a half. Okay, and sine theta is equal to opposite over hypotenuse, right? So opposite hypotenuse. So that means that the y value, okay, the opposite must be negative, which is why we're in these quadrants. Okay, so that's a start. Now it's just a case of saying, well, all right, if we go from here to get to here, what does that angle look like? Well, we can say that theta is equal to that's going to equal pi, which is this bit. And what's theta? Well, sine of a half, just normally, okay, is equal to pi over 6. Okay, so you've got theta plus pi over 6, which equals 7 pi over 6. Okay. Meanwhile, to get to here, what do? We minus from 360 degrees. Okay, so we've got 2 pi minus pi over 6, which equals 11 pi over 6. Okay, and those are going to be your final answers. So this makes it a lot easier. You can never, this method is almost foolproof, okay, because it makes it very easy to work out the angles instead of just doing like 180 plus pi, which is the common technique. Alright guys, now for this one, we've got cos x times cos 2x plus sin x times sin 2x. Okay, and this equals root 3 over 2. So where do we go from here? Well, if you remember your compound angle formula, right, this over here can be rewritten. Okay, it can be rewritten. And what can it be rewritten to? Well, we can say that this is going to equal cos of x minus 2x, right? That's what it can be rewritten to using the compound angle formula. And that's equal to root 3 over 2, right? Now what is x minus 2x? Well, that's minus x. Okay, and from that, okay, from that now, what does that tell us? Well, minus x, you see all the identities are coming together. Cos minus x is the same thing as saying cos x, right? So therefore I can say that cos x is equal to root 3 over 2. Okay, now let's go back to our cast diagram. Okay, because this could very easily trip you up, but using just drawing the triangles makes a huge difference. Okay, so where is cos positive? In these quadrants, right? It's positive in those quadrants. So what do? Right? Let me draw a triangle here. Right? And what is cos? It's adjacent over hypotenuse. Okay? we've got x here, root 3 here, we've got 2 here, and we've got a corresponding triangle over here, right? Still got the root 3, right? Got 2 here. And so what does this tell us? Well, first off, we've got the reference angle here, right? Which is simply done by just finding arc cos of root 3 over 2. And that's going to equal pi over 6, okay? Pi over 6. Meanwhile, we know that over here, what do? Pi over 6 is minused from 2 pi. Okay, so x is equal to pi over 6, or x is equal to 2 pi minus pi over 6, which equals 11 pi over 6. Okay, now what's our period? 0 to 2 pi. Okay, and cos obviously has its own period of 0 to 2 pi. And if we were to add 2 pi to any of these, or minus 2 pi, it would be out the range. So therefore these are your final answers. Alright guys, now for this one we've got cos 2x is equal to a half. Okay, and this is in between 0 and 2 pi. So, again, pretty simple question, but it's all about building the foundation, particularly with the cast diagrams, because that's where you get where people slip up. So we've got 2x here, and that's going to equal arc cos of a half, right? So therefore 2x is going to equal what? Pi over 3. Okay, it equals pi over 3. So 2x equals pi over 3. I'm going to say this. I'm going to say let 2x equal theta. Okay. So if I draw my diagram now, what we have is the following. Okay, where is cos positive? Cos is positive in these quadrants. Okay, so I'm going to draw on these quadrants. Okay, we got theta here and theta here. Okay, and what is cos equal to? Adjacent over hypotenuse, right? Perfect. So, our reference angle here is 2 pi over 3. Okay. Theta equals 2 pi over 3. Okay, and if we want to go around here, we need to get rid of this. Okay, and so theta is going to equal pi over 3, or theta is going to equal 2 pi minus pi over 3. Okay, which is going to equal 5 pi over 3. Okay, so therefore, what we've got here is pi over 3 or 5 pi over 3, but really what we've got okay, times n dot 2 pi. And if we add, if n equals 1, we get theta equaling 11 pi over 3, or theta equaling 7 pi over 3. If n equals 2, okay, theta is equal to 17 pi over 3, or theta is equal to 13 pi over 3. Now I've gone the long way here. You could have done the next bit before, but just for demonstration's sake. What we then get, okay, is a realization that since theta is equal to 2x, okay, since theta is equal to 2x, what we get are x equaling pi over 6, 5 pi over 6, okay, and 7 pi over 6, and 11 pi over 6. Now how did I get to this answer? These don't count because they're bigger than 2 pi, so obviously they're going to be out of the range. Okay. Sorry. I should rephrase. When you divide these by 2, 17 pi over 6 and 13 pi over 6 are bigger than 2 pi. Okay, so they don't count. Meanwhile, these sets, when divided by 2, they're within the range. So hence our answers here. Alright guys, so here we've got a little bit more of a difficult-esque type question, right? So it looks intimidating, but really it's not that bad. Okay? So 2 sine x plus 3 sec x is equal to 6 plus tan x, right? Solve. Solve. So what this is going to equal is we've got 2 sine x, okay, sec, well it's 1 over cos, so we got plus 3 over cos x is equal to 6 plus sine x over cos x, right? Now what's the common denominator? What's the thing we need to multiply by, okay? That's going to equal cos x, right? So when we multiply by cos x, what we then get is 2 sine x cos x plus 3, right, because we multiply out, it's going to equal 6 cos x plus sine x, right? And from here, we can say, all right, we get 2 sine x cos x minus sine x is equal to 6 cos x minus 3. Right, so you see where we're going with this. Because from here, what we can do is take out a common factor of sine x. Okay, and when we do that, we get 2 cos x minus 1 over here. We set that equal. Okay, we get 2 cos x minus 1. Okay, so what we then get is we can say sine x, okay, 2 cos x minus 1 minus 3 2 cos x minus 1 is equal to 0. And as a result, we can then take out a common factor. And when we take out a common factor here, we get 2 cos x minus 1 times sine x minus 3. Okay, that equals 0. Right? Now, that leaves us with 2 answers. So we've got 2 cos x is equal to 1, which means cos x is equal to a half, or sine x equals 3, right? But obviously here, sine x can't equal 3. Okay, it can't. So that leaves us with cos x equals a half. Now this is where our cast diagram comes into play. Okay, so if we draw this properly, we know that cos is positive in these two quadrants. Okay, so if I draw my triangles, like so. A little bit skewed, but that's fine. Put theta here and here. Cos is equal to what? Adjacent over hypotenuse, right? So we put 1 here, 2 here, and 2 here. Right? And so what does that give us? Well, in the first instance, we get theta is equal to pi over 3, right? Arc cos of a half. Or, okay, we apply it here. Theta is equal to 2 pi minus pi over 3, which equals 5 pi over 3, right? So these are two answers. And obviously, we've got our range, our bounds here. But cos x has a period of 2 pi. So we've got theta is equal to pi over 3 plus n dot 2 pi. Or theta is equal to 5 pi over 3 plus n dot 2 pi. Okay, now it doesn't matter what value you put as n, we're only going to have pi over 3 and 5 pi over 3 because anything else is going to be outside the range. So therefore, theta is equal to pi over 3 or 5 pi over 3. Alright guys, now this one looks a little bit more intimidating, but it actually isn't once you break it down. Okay, so this is all just about applying our trigonometric identities and seeing how we can weave everything together. So, what we've got here is sine squared tan x. Okay, tan x is what? Sine x over cos x, right? Then we're adding cos squared x. Okay, and cot x. What's cot? 1 over tan x, which is 1 over sine x over cos x. Okay, so we can flip the entire thing. So if we do that, we flip the entire thing. What we've then got is cos x, okay, over sine x. And then we add 2 sine x. Cos x equals 2. Okay, now let's multiply it out. If we do that, we get sine cubed x over cos x plus cos cubed x over sine x plus 2 sine x cos x is equal to 2, right? And from here, we're going to multiply to simplify the equation. So what do we multiply by? Well, we're going to multiply by sine x cos x. So if we do that, we're going to get sine to the power 4x plus cos to the power 4x plus 2 sine squared x cos squared x is equal to 2 sine x cos x, right? Now, we can break this down further, because this here, right, it can be made into sine squared x. In fact, sorry, the entire thing, sorry, can be made into the following. Okay, it can be made into sine squared x plus cos squared x squared, right? Because that, if you expand this out, this is what you get. And we're going to set that equal to 2 sine x cos x. Okay, Now what is sine squared x plus cos squared x equal to? That's 1. So 1 is equal to 2 sine x cos x, which means that sine 2x is equal to 1. Alright? Brilliant. So we've hit the first stage. We've hit the first stage, right? So let's see what we got here. So 2x is equal to arc sine of 1, which is going to equal 90 degrees. Okay. Now I'm going to say let 2x equal k, right? So we know then that k is just going to equal 90 degrees. But we also know if we draw a cos diagram here, okay, we also know that sine is positive here. Okay, so our reference angle is 90 degrees. Okay, our reference angle is 90 degrees, so then we've got what? 180 degrees minus theta. Well, it's just 90, right? So we're just going to stick to 90 degrees. And so we can say that 2x is equal to 90 plus n times 360 degrees. Okay, and we're doing that because we obviously were working with sine here, right? And therefore, x is going to equal 45 times 180 degrees, right? Now, in terms of the bounds here, what you can work with, you can then say, okay, x is equal to 45 plus n dot 180. Well, if we add n equals 1, okay, if we make n equals 1, okay, remember our period over here is 360. Therefore, x is going to equal 225. So therefore, x is going to equal 45 degrees or 225 degrees. Okay? And those are going to be your final answers for that question. Alright guys, now for this question we've got sine y times 1 plus tan y plus cos y times 1 plus cot y is equal to 0. Okay, and y is in between 0 to 360 and it can't equal these values. So how do we go about solving this now? Well, let's expand it first. So we get sine y plus sine y tan y. Okay. I'm going to add cos y to that. And then we get cos y cot y is equal to 0. Okay. So let's expand this out. So we get sine y then plus sine squared y over cos y plus cos y plus cos y times cot y. So that's going to give us cos squared y. Okay, cos squared y over sine y. Okay, it's all going to equal 0. So, what are our common denominators, or what do we need to multiply by? Sine y, cos y, right? So, if we do that, what do we get? Well, what we get is sine squared y, cos y, plus sine cubed y plus cos squared y sine y plus cos squared y is equal to 0. Right? Now, with that, if I take out sine squared y, we can get cos y, okay, plus sine y plus cos squared y sine y plus cos y is equal to 0. Okay. Now we've got a grouping factorization situation here. Okay, because what we can do is we can say cos y plus sine y, okay, times sine squared y plus cos squared y is equal to 0. This is going to cancel because this equals 1, right? So therefore we've got cos y plus sine y is equal to 0. And we can simplify this down to say, well, 1 plus tan y is equal to 0. So tan y is equal to negative 1. If tan y is equal to negative 1, okay, tan y is equal to negative 1. What does that tell us? Well, tan is negative in these quadrants. Okay, so I'm going to draw a triangle here. Draw a triangle here. Draw theta there. And so, what does that give me? Well, if we're going here, okay, first of all, what we need to find here is just tan of 1, okay, tan of 1, and that's 45 degrees, okay, because that's what this represents, okay. So arctan of 1, right? So therefore, our answers are gonna be 180 minus 45 degrees, which gives us sorry, y. I don't know why I'm saying theta here. Principle's the same though, right? So y is equal to 180 minus 45. Y is equal to 135 degrees. Or y is over here, where again we go the full loop round. Okay, so we get y is equal to 360 minus 45 degrees, which gives us 315 degrees. Now naturally these are both within our our bounds here, right? And we can't add anything else as a multiple of 360, so of 180, to get within the bounds. Okay, so these are going to be our final answers here.